Uh, Good afternoon, everyone. My name is Mr. Mofokeng. I'm going to present. Uh, I'm going to present the algebraic equations as a revision for grade 8. Right. So let's get started, my dear grade 8 learners. Right. As I've indicated, we are just going to do the revision for presentation for algebraic equations. Now, we are going to do equations whereby we will be using additive inverse and multiplicative inverses. And then also we are going to do activities on using laws of exponents. We solve equations on using laws of exponents. Right, so let's get started. For the first activity, we are having x minus 3 being equals to 5. We have to solve for x. So that simply means in order to solve for x, we must apply or use the additive inverse. So now, in order to use the additive inverse, we must isolate the variable x by adding positive 3 on the left-hand side as well as on the right-hand side. So by so doing, it simply means we are going to have x plus 0 on the left-hand side. Therefore, we will be isolating x. And then on the right-hand side, we will be having 5 plus 3. And then the next step, it will be x is equals to 5 plus 3. Right. So this 5 plus 3, most of the time, the learners would say, but why can't we say we have taken negative 3 on the left-hand side to the right-hand side? Yes, we did that by applying the additive inverse. So it is not just to move something from other side to the other side. We must apply the proper method in order to move 3 to the other side, negative 3 to the other side. And therefore the answer will be x is equals to 8. Right, moving to the next slide. The next slide, we are having negative 2p plus 5 is equals to 1. And as a result, we must solve for p. Right, let's get started. Here we are having negative p plus 5 is equals to 1. And we must apply the additive inverse by moving positive 5 to the right-hand side. Here we are. We add negative 5 on both sides so that on the left-hand side, we will be having negative 2p plus 0 because 5 minus 5 will be 0. And then on the left-hand side, we will be having 1 minus 5. And then moving forward, we are having negative 2p is equals to 1 minus 5 because 5 minus 5 is 0. We are left with negative 2p on the left-hand side. And on the right-hand side, we are having 1 minus 5. And then you can also again associate negative 5 with positive 5, the initial positive 5. One would say, I've taken positive 5 to the right-hand side and it changes sign to negative 5. But that it happens because we have applied the additive inverse. All right, the next step, we are having negative 2p divided by 1 because negative 2p is the same as negative 2p divided by 1. And as well, 1 minus 5 is the same as negative 4, which will be negative 4 divided by 1. Now, we must apply the multiplicative inverse in order to isolate p by moving negative 2. Here we are. We have multiplied by negative half, which is the multiplicative inverse of negative 2 divided by 1. We do so by multiplying both sides. And then we ultimately have negative 2 p divided by negative 2, as well as negative 4 divided by negative 2, because we have multiplied 1 by negative 2, it will give us negative 2. P, we multiply negative 2 by 1, it will give us negative 2. On the right-hand side, we multiply 1 by negative 4, it will give us negative 4. And then we multiply negative 2 by 1, it will give us negative 2. And for this step, it is clear that most of the time, when we solve this from negative 2p is equals to 1 minus 5, we will be saying you divide by negative 2. Yes, this step shows exactly that we divide by negative 2. But where it started? It started whereby we have actually applied the multiplicative inverse. So be aware that whenever we solve the equations, if we have to move the coefficient such that we are left with the variable, we actually apply the multiplicative inverse. Hence, I'm saying if you see negative 2p being divided by negative 2 and negative 4 being divided by negative 2, it is because we have actually multiplied by multiplicative inverse of negative 2 over out of 1. So it will give us negative 2 out of negative 2 being negative 4 out of negative 2. Right. Then here we go. The answer will be P is equals to 2. And then moving forward, solve equations using laws of exponents. Right. In solving the equations using laws of exponents, let's get started. Right, we are having 2 to exponent of x being equals to 8. So in this case, we need to solve for x. Right. 2 to exponent of x will be equals to, we have to actually represent 8 as base 2. So representing 8 as base 2, it will give us 2 to exponent of 3. So 2 to exponent 3, it will give us 8. So we have actually not changed anything. 2 to exponent of 3 is the same as 8. So we have just expressed 8 as base 2. And then again, after ensuring that the bases are the same, it is now easier to can equate the exponents, because the key thing is, if we are having 2 to exponent of x is equals to 2 to exponent of 3, for us to have our equation being balanced, it means the value of x must also be 3. But in mathematical term, we will be saying we equate the exponents, therefore x is equals to 3. I hope we are all together. Then we go to the last activity, our last activity. Right. The last activity, we are having 2 multiplied by 5 to exponent of x minus 2 is equals to 50. As we have actually indicated that we are actually solving by using the laws of exponents. Here you will realize that under no circumstances, we can multiply 2 by 5. Under no circumstances. Why? Because we are dealing with 2 to exponent of 1 multiplied by 5 to exponent of x minus 2. And the 2, that 2 and 5 to exponent, the base 2 and base 5, they are different. So there's nothing we can do about 2 and 5. So we cannot multiply 2 by 5 while the bases are not the same. So the least we can do is just to isolate 5 to exponent of x minus 2 by dividing throughout by 2. In fact, by multiplying throughout by half, of which we will be applying the multiplicative inverse. Right, here we are. Dividing by 2 is the same as multiplying by half. You did so when we were dealing with the multiplicative inverse in the previous question, in question 2, in problem 2. Now, in this case, we have divided by 2 because we want to get rid of 2, therefore we multiply by a half, which will ultimately seem to be dividing throughout by 2. Right, and then moving forward, after dividing by 2, we have 5 to exponent of x minus 2 being equals to 25, because 50 divided by 2 is 25. Right, and then again moving forward, as we did with number 3, we have to express 25 as base 5. So expressing 25 as base 5, it will be 5 to exponent 2. Right. And then because we have already ensured that the bases are the same, now we can equate the exponents. So in equating the exponents, it simply means x minus 2 will be the same as 2. X minus 2 will be the same as 2. Right. And then moving forward, we will be having to add positive 2 on both sides. And adding positive 2 on both sides, we will be applying the additive inverse on both sides of the equation, of which when you add 2 on the left-hand side, it will be 0. But on the right-hand side, when you add 2 to 2, it will give you 4, of which x is equals to 4. Right. Now, this was the last problem that we were dealing with. I've actually posted the quiz in the chat, or rather in the group, whereby you will actually deal with it and then see how far are you. But what I want to say is that my grade 8 learners, you will be writing your first paper on Friday. Please ensure that you practice. And one key thing is that this issue of equations, it is across the grades. You'll go to grade 9, you are going to come across it. You'll go to grade 10, grade 11, and grade 12. And I think even beyond grade 12, you will be dealing with the same thing. So it is very much important that you understand what is basically happening in the space of the equations. And I hope what I did today, it will help most of you who did not understand what is happening. The key thing that you need to understand is that you must apply the additive inverse. You must apply the multiplicative inverse. You must also ensure that in solving the laws of exponents, you ensure that you make the bases to be the same, then you equate the exponents. Whereby you are having you multiply different bases, you must start firstly by dividing by the constant number, or rather the coefficient, before you can equate the exponents, or before you can make the bases to be the same. It will be easier to do that. I hope this lesson was fruitful to you. Thank you very much. This marks the end of our lesson. Thank you very much.